is and what it enables you to do. Okay, so that's one thing. Before we start ahead, Mr. Amul has a question. He's saying that I have last file and I tried visualization. Can you show us how to do that? Yes. Mr. Amul, last files is actually, it's not covered in this webinar, but if you join the full training, I also teach our students in this training how to convert last files into databases or how to just keep it as a last file. If we have like a couple of minutes left, I will try to demonstrate to you how we can actually visualize last file, but it's going to be very fast one. But I think you can get a grasp of what you can do with it. So that's since that question is out of the way, so let's start doing this webinar. Okay, so our question is, why do we need to learn SQL, or why do we need to learn data management? Well, since we get a lot of data and oil and gas operations are getting diversified and too much personnel now is being involved in the process, suddenly we find ourselves with too much data. And this too much data is actually creating a problem with us. No one knows which is the final version or the true version of the data, because the more versions of something you have, the more doubt you have about that particular thing. But if you have, let's say, a single book or a single data file, well, your obligation is to use that single file or that single book because you don't have an alternative. But the problem starts with whenever you start to have versions or alternatives. So that's just one way of thinking of this. So let's see how we can utilize data management, Python, SQL, dashboards, and how basically these can be used in oil and gas industry. So number one, if you learn these knowledges, which by the way, which is very important, it allows you to standardize and basically create workflows that are repeatable, accurate, fast, and very efficient. So that's number one. Number two, it allows you to save different types of data. For example, have you ever wondered how we can manage PDF files for different drilling reports or from different drilling, from different production reports or from job reports? Have you ever thought about that? So is saving everything in a single folder, is this the best answer or this is the best approach we have? The answer is no. We can combine these with databases, and with a little bit knowledge of Python and database, we can create a unified interface where the user can retrieve, search, query, or even create an artificial intelligence agent that reads those files for him and summarizes these. So these are just some of the possibilities. Plus, whenever you have all the data in single place, retrieving those data is going to be much more easier. Plus, if you know how to deal with data management with SQL and Python, you can easily integrate, well, not just tens, even hundreds of data sources together. Because what we have usually in oil and gas industry, people are divided into two groups. Either people working with commercial softwares like Halliburton DSS, Sahara, OFM. So we have those people who basically dedicated to these commercial softwares, which are, by the way, great softwares to begin with. We have some other groups that work with Spotfire and other similar caliber technology, and we have other people that work solely on Excel. Each tool has its own strength and weaknesses, but a best approach would be to combine everything together and add into the mix data science, SQL, data management to make every single source of data count. Some softwares cannot read particular data formats, but in Python that's possible. For example, when was the last time you started to read log files or data log files, for example, from PLT inside Spotfire or inside any other commercial software? Well, that's not possible. But in Python, you can just read pure and raw LAS files. So these are just few things. Plus, there are other benefits like keeping the data quality and ensuring the data integrity, maintaining extremely high quality of the data, plus having the recent and updated data always, plus ability to create automation. We can have increase in performance, scalability, and more efficiency towards driving workflows. Basically, we have lots and lots of things to consider whenever we're trying to do these things. Okay, so without further ado, let's go ahead and let me show you a few things in the code. Okay, so yesterday was almost everything was theoretical except for the last part actually happening in the background. Okay, so let me show you. I will open up the same SQL window that we have seen yesterday, but today I am not going to copy and paste data. I will pull data directly from SQL. Not just that, I will create a very simple application in Python, and you will see how simple it is. This simple data application or analytical application, I will link that to SQL, and then I will show you how to browse that application from somewhere else than your computer. This can be your tablet, your phone, or even you can publish this online. But this is not very encouraged, by the way, because publishing data online it's a little bit problematic. But that's an option which you can do, by the way. So the main target for us is if we wanted to create a dashboard for analytics, what we need to do is we need to connect to this server, right? So this is exactly what we are going to do. So we will create a Python file, and that's this Python file. By the way, the software that you use for this is not very important. The important thing is the idea, because Python have many, many softwares. So basically, we have an import section where we are importing many libraries. We have pandas, which reads basically tables for us. We have Streamlit. Streamlit is the application, or let's say it's the library that builds dashboard. Believe me when I tell you, we have been adopting Streamlit from 2022, so from 2020. So that's almost more than 3 years. So Streamlit, we explain Streamlit in each and every training we have because it's extremely important. It's one of the greatest tools that you can learn in Python. It basically allows you to create analytics and data applications. Plus, we have Plotly. Plotly is just a library to create your visualization because most programming languages do not have the ability to create plots. Well, how do these programming languages create plot? By using something similar to Plotly or Plotly itself. Basically, these languages are you can think of these languages as a Lego bricks. Everything is interlocks and everything expands the original solution. So basically, this is what we have. So we have the connection. Connection is just a simple code that I wrote to simplify everything. By the way, usually we share this connection file because this connection file is a particular file that we write and share it to our colleagues. Plus, we also teach them how to write this file. It basically makes everything easier for you. Okay, so once you have everything imported out, now it's time to start writing our application. So the first thing that we want to do in order to write our application, let me put everything side by side. So I want you to see what's happening while we program this. Okay, so basically this is our application. On the right-hand side, this is the empty screen. This is the application. We are going to use this empty screen in order to create a dashboard, an analytical tool, and basically create some calculations as well. Why not? So the first thing that we would love to do is add a simple title to this, right? Because we need a title. So we will do Streamlit, which is the name of the library, dot title. And you can have anything you want. For example, let's do this like live SQL, or let's create this live database management dashboard. Once you save it, the result will always going to reflect on the screen right away. So this is number one. Number two, now it's time to start reading data, right? Because data sits in SQL, so that we need to start reading that. So how can we read it? Well, if you pay a visit to other programming languages, you will find it extremely prolonged method to read data from SQL. But in Python, For some reason, they made it so simple. It's actually just a single line of code. Let me show you. First of all, let's create a connection to this database. So I will call the connection CON. You can name it whatever you want, by the way. Connection equals to connection dot connect to field database. You can have different database connection. You can have any database you want. You can have X and Y database. You can have Burgon database. You can have any connection to any database. You control this 100%. I am doing this because I want to make everything simple. Once we have this connection, believe it or not, that's it. You don't need to do anything else. Let me show you. Now, we have a table in this connection. It's called X and Y. So this is going to be the main table, right? These tables actually contain all the data for the wells. It contains the data for the total depth and the completion data and whatnot, right? So what I will be doing is I am going to use the server to execute the code, which is the SQL query. Whenever the query is 100% working, what I'm going to do is I will copy the query just like this, and then I'm going to be pasting it in Python. And let me show you where the connection usually happens. And this is one of the places where the people misunderstand how Python is different from SQL, because SQL is just the engine for the data, while Python does everything else for you. So we will create a table called wells. These are going to contain everything for you. So these are just the wells. So wells equals to pandas. Pandas is the library that basically reads data for you. And one of the most powerful thing you can find in any programming language is there is a function called read SQL. This read SQL function is so powerful. It allows you to read SQL directly into a table, which is unprecedented, by the way. And we can paste the select all from X and Y. And believe it or not, that's it. You don't need to do anything else about this. Now, you might ask yourself, well, what's happening to the results? Well, the results, it's already there, but you don't see it because it's not presented. So if we go and do something like streamlit.table, just view the table of wells, save it. There you go. Now you can see the results coming from the database. So I can prove you that this is an interactive thing. Let me show you. Maybe you want to get information about just a single well. Maybe you don't want each and every well. That's a possibility. Let me show you. Do you remember when I talked about the possibilities of using data management and SQL? And one of the things that we did is actually having multiple sources at the same time? Well, that's true. Let me show you. I will create another simple table, but this time the table is going to only include the name of the well. So instead of selecting everything, I'm just going to select the name of the well. I'm going to use those names of the well to allow the user to select something. So I'm going to allow some flexibility. There is one thing else. If you remember from yesterday, there is another table called full header. This full header table contains everything. For example, we have tables, we have wells that are gas, we have wells that are oil, and basically we have wells that are injectors, right? So what I'm going to do is I'm going to retrieve two pieces of information only. I'm going to retrieve the name of the well, and then I'm going to retrieve the status of the well or the type of the well. So once I do this, I'm going to get two columns. And based on these information, I can drive and create decisions in my application so the user can do whatever he wants. By the way, I'm slowing down in explanation because I want you to understand what's happening. But whenever you grasp the basic knowledge of this, you are going to work very, very fast on these things because it's very easy. So I will copy the query I made. So what I will do, well, I am not going to do anything new. I'm just going to copy and paste this line, just like this. You don't need to do anything else. Once you create this line, well, now you get two data sources. Instead of calling these wells, I'm going to call these names. And instead of for this from being select from X and Y, we are going to use this line that we have just written. So we are copying, pasting, and just like this. Now we have the names as well. How can we utilize names? Well, we can utilize names to allow the user to select those wells. So let me show you. I am going to use streamlit.sidebar. Sidebar is just something on the left-hand side. The user can place components on it. So radio names.uniqueID, and of course, we can provide a label for the user to do whatever he wants. For example, let's say select a well. Let's save this. There we go. Now, do you see this sidebar? This sidebar is the user, something that user can select. And you can filter this further down by the type of the well. For example, maybe you want only gas wells. Maybe you want water wells. So let me show you, if I'm not going to do that, but let me show you if you want only gas wells, what you're going to do. You will do something like where status equals to, for example, let's say we want only gas wells. Once you do that, you're only going to get gas wells. Maybe you want the injection wells. You will do equals to water injection, and then you will get a blazing fast filtering on the database. So once we have that, now the user can select whatever data he wants, he wishes to use. One thing is, now, instead of just having every piece of information viewed as a static thing, we will allow the user to select whichever well he wants. And based on the well selection, we are going to filter down this table. So let me show you. Everything is going to remain the same. The only thing is different now is now we need to condition this query. So we will say where, for example, unique ID, which is the name of the well, equals some particular thing, for example, plus the name of the well. So let me show you. It's going to be, for example, something like this. Let's say that this is the name of the well we are selecting. Just like this. We can save this. There we go. Now you are only going to get a single well. Of course, you can automate this and then link this component. For example, let's call this selected well. And whatever you have in this selection, that can also be something that the user can select based on. So let me show you. So let's save this. There you go. Now you can see whenever you select a new well, that well is or the data for that well is going to reflect on these tables. Now, this is just the main information. What happens if you want to get more detailed information, maybe about the production or maybe about the injection? Well, that's also a possibility. Let me show you. So if we want to get the production data, we will create another table called production equals to pandas.read underscore SQL, and we have the connection. We only need to write the query. And the query, I am going to copy and paste the same query. You can see there is lots of copy and pasting, but the important thing is you need to understand what's happening. So we're going to select everything from PRD. And once we do that, we can also show the PRD. So let me show you. We can also show another table, .table, PRD. Let's save this. There we go. Now this is the production data viewed as a table. Of course, whenever you change your well, you're going to get different results. Now, the important thing is how we can utilize these for plotting, right? Let me show you. We can easily use Plotly for this. So if you want to create a historical plot, we will use Plotly line plot to do that plot for us. So we will feed our production data, and on the x-axis, we will make sure that we are setting the date. By the way, this is also something flexible. It does not have to be date always. It can be anything you want. It can be representing the heterogeneity index. It can be representing the x and y coordinate. It can be represent different parameters and variables, especially if you're trying to create a correlation depending on single or multi variables. So for y-axis, we can do few things. For example, for the y-axis, we can plot the water and oil, both of these at the same time. Once we have these historical plots already set up for us, we can do something like this, streamlit dot Plotly chart, and we will plug in the historical chart we did, and then we will save it. And there we go. Now this is your historical plot. If you change this to another well, just like this, you can see you're going to get dynamic data being pulled from SQL database as we are working with this. Now, do you see this? These are different things that are being pulled from the database. Usually, there are some pieces of information that we want to present. By the way, I would be pausing this table from printing out. Maybe you don't want to see the full table. Sometimes the full table is just annoying. Maybe you want to see only few lines of the table because everything now is being presented. So what I will do a very simple trick. I will say only get the heading data of, for example, let's say 5 lines. So this will limit our table just to 5 lines. You can select any number of lines you want. This is the historical data. Now, what happens if you want to view the full production for the field, right? Not just a single well. Well, we want to keep this, but we also want to add the full production for the field, right? Let me show you how we can do this. And it's way, way simpler than you think. We will create a table, full data equals to pandas.read SQL. And in the query, we will type select everything from production, and that's it. You don't need anything more than that. If you pay attention, you will see that we have 1, 2, 3, and now we have 4 different data sources being pulled into this application. You can see how flexible this is. Let me show you how we can create an extremely amazing plot with as just a single line of code. And this plot is going to be for the full field. Let me show you. So I will call this field plot equals to plotly express. Now it depends on what you want to do. You can create a line chart, or you can create a scatter chart, or you can even create both. Let me show you how we can create a line chart. We will do a line, and then we will pass in the full data. And the x-axis is going to be the date, as usual, and the y-axis is going to be anything you want. For example, maybe you are interested in the oil production, or maybe you are interested in the gas production. Let's save this. If you save this, you're not going to see anything change. Why is this? Because you are not viewing the plot. Let me show you. We can push this chart, we can push this table below. We will view this table below. What I will do is I will make some room for the full field chart. So this is going to be Streamlit dot plotly, and then we're going to pass in the full underscore PLT. Okay, now one thing left is those charts do not have any labels. So we can utilize the title to make this as full field history. Let's save this. Let's see, it says that the name was not there because actually we're not using the correct name. That's why. Let's save this. There we go. Now this is the full historical data of your field. I know it's not looking very pleasant because actually we are not doing the correct color coding. Now, if we zoom in on this chart, I know it's messy. We are going to fix this in a couple of seconds. But if you take a look at each line of these represents actually a particular well. Let me show you. Instead of just having everything unified in color, what we can do is we can break down these lines by color based on their well names like this. Save it. There we go. Now you have the fastest and the best chart you can use. And of course, you can turn off any well that you don't want by just interacting with the chart. Let me show you. Maybe we want to see only 3 wells. For example, you will double click on any of the wells, you will get only that well. Okay, so if you want to compare that with other wells or other assets, you can just start clicking and add more data to this. This is the best thing that you can do in Python whenever it's related to just a single line of plotting. It cannot get much more powerful than this. Of course, you can change the settings also to view in dark mode. Dark mode is something also pleasant that we usually see in these types of applications, especially for people who have some eye strain or some problem with the vision. Dark visualization is also something good to see. Now, let me just bring to your attention something we did yesterday. Just give me 1 second to pull up yesterday's example. Now, if you remember from yesterday, we used the clipboard. So we did something like this yesterday, select all from full header. We ran this and then we selected everything, but we're not doing this today. We do copy header, and then if you remember correctly, yesterday what we did is we generated this contour map, right? Now let me show you something. We can copy the same code. Nothing is going to change. We're copying the same code, and then we're going to put it into our dashboard. And then once we put it in the dashboard, it's going to work right away. Let me show you. So we will show, let's say, the full contour map on the top. By the way, there are many ways to organize this chart. I know it's now seems messy, but there are lots of ways to organize this. Let me show you something. We have this wells. It's basically the equivalent of the full header, but it contains all the information we need. So what we're going to do is I'm going to paste our figure in here, and we are going to use wells as the source for the data. Once we have everything ready, I am going to use plotly chart and just show the figure just like this, save everything. There we go. Now we should have all the data being presented. So let's see what's happening exactly. Yep, this is basically just showing a single well. So we can also create for all the wells. That's also a possibility. Let me show you how. So we will create another data source for all wells equals to the same thing. Just copy and paste that. And we are not going to have any selection or anywhere condition. We don't want that anymore because we're only interested in all the wells. So we will say all wells, save this. There we go. Now you're having the same exact contour map that we did as yesterday. You can see you can do lots and lots of things of this. For example, one of the things that you can do is you can calculate the total, for example, something or the total production coming from these wells. Okay, so the total production, and you can present that as a metric. A metric is just a card that you can display or visualize on the top. Let me show you how we can do this. So what I'm going to do is I will be utilizing the production data to show how much we are basically getting from oil and gas, right? So let me show you. We are going to present it on the top. So total production. I'm going to just copy the production, which is this one. Let's copy this and paste it below. And we're not going to use any condition because we want the total production of the field. We're not just looking for one well, but if you're also looking for one well, that's also a possibility. Now, let's do one thing. I will create a variable for total oil equals to production.oil.sum. So this is going to be the total production for the oil. We can also do the same thing for the gas. So total gas equals to production.gas.summation. So now we have these two values. We can present those in a card or a metric that's going to be displayed on the top. Let me show you how we can do that. We will use a very nice functionality in Streamlit called a card. So Streamlit, called a metric. We open the parentheses and now it requires a label. So we will say to date cumulative gas produced or produced, just like this. And the value for this, it can be the total gas. And we will save this. Now we are going to get this card. By the way, you can also change the color for this card. Now this card is basically the data. That's basically the total for the gas, right? You can also create a total for the oil. So let me show you. We will copy and paste the same thing. Instead of for the total gas, we're going to use the total oil. And we will do that. Save it. There you go. Now this is the total oil. If you're interested in for the total GOR from the field, which is, to be honest, which is not a very correct move in here, but let me show you how we can do that. So what we are looking for is we are looking for the cumulative total gas over total oil. So that's just a calculation thing. So we will do total gas over total oil. So we will do cumulative GOR calculation, save it. There we go. Now this is the total produced GOR, which is, this is in M standard cubic feet. So let's delete this integer, save it. There we go. Now this is the value. We can multiply this by 1,000 because this value has a multiplier. There we go. Now this is the total GOR from this field. Now we are almost finishing up. And before we move, before we finish this session, let me turn off my screen. And now I will be sharing the screen from my laptop. From my tablet, because on my tablet, I'm also connecting to the same network. So let me show you how we can visualize the same application that we just did on other machines that are basically working on the same network connection. Let me show you. Just give me a second. Mr. Nakhil, can you just provide an access for me on my other device?
Sure, sir, done.
Thank you so much. Now it's working. Now you guys should be able to see the screen from my tablet. So what I will be doing is I will be punching in the address for the application, which is going to be just an IP address. Each person will have his own IP address or her own IP address. So you need to make sure of that. So the IP address to my application is this one. And then we're going to add the final part, which is 8501, which is the number of port. There we go. Now this is the same application that we just ran on our PC. There we go. By the way, the application might seem slow, but to be honest, it's not slow. It's actually the Zoom platform making it slow. So let me show you how we can interact with this application. Of course, you can just view this or visualize this application the orientation you want or on the device you want. The beauty of this is this application or this technology is based on web, so it's expected to work on anything. So first of all, we can interact with this by changing the setting to wide mode and make sure that this system is set to dark. So it emulates what we have seen in the Windows environment. And now you can also interact with these plots by selecting and deselecting whatever well we want to visualize. You can see this is all happening from my tablet. Plus one thing else you can do is if you scroll down, if you scroll above, you will see that this middle chart is empty. Why is this? Because we don't have any well selected. If you expand this button, you will get all the wells. Now, do you see? These are the wells that we have in this application. And I'm getting everything pulled directly from SQL into my tablet. So you can see how beneficial that can be. Let's open up other wells. Of course, we can also maximize this chart like this. We can take a screenshot for this chart. It's ask you where to download. We are going to download it on my downloads. We will say keep the file, and we can also open it. This is the chart. Thank you so much for joining in. Hopefully, you learned lots of new things. One final thing left before we move forward is how we can read LAS files and how we can integrate it into our application. Luckily for us, there is one nice application, or there is one nice library that we can use for this purpose. It's called Lasio. So we can do something like import Lasio as ls or as anything you want, and then just target our LAS file with this. Let me switch back, sharing the screen. Now I'm shifting to my laptop. Let me find a LAS file for you guys so you can see how we can visualize this. Let me find a LAS file for you guys. There we go. This is one of the LAS files. Let's copy the path to this LAS and then we utilize it. So LAS file equals to, let's say, lasio.open, or sorry, .read. We are going to read this file. And then once we read this file successfully, we can also visualize the LAS file data. So let me show you. So we will do something like this. Streamlit.table. Let me show you the table version of this LAS file. There we go. This is now our LAS file being visualized as a table. Of course, you can just create a plot as you wish. You can create a plot for SP. You can create a plot for the gamma ray. The important thing is now you have this LAS file read and extracted. Now, what you can do next with this LAS file, you can convert this LAS file into database, or you can interact by selecting the name of the well from the database to pull up the LAS file from different place in your PC. Hopefully this answers your question, Mr. Amol. Thank you so much, everyone, for joining in and dedicating the time for this session, and over to you, Nikhil.